Graphing Systems of Inequalities, Part 1. Graph the solution set of the system of inequalities. Here I have two linear inequalities. In order to graph the system, I'm going to graph each linear inequality separately on the same coordinate plane and then shade the overlap of the inequalities. So first, we're going to take the top inequality, which is 3x minus 4y is less than or equal to 12. And I want to find the x and y intercept in order to graph the line. The x-intercept is found by substituting a 0 in for y. And I want to change the inequality sign to an equal sign. So I have 3x minus 4 times 0 equals 12. That's 3x minus 0 equals 12, which gives me 3x equals 12. And then when we divide both sides by 3, I get x equals 4. So my x-intercept is 4, 0. Next, we're going to find our y-intercept. And the y-intercept is found by substituting in a 0 for x. So I have 3 times 0 minus 4y equals 12. This gives me 0 minus 4y equals 12, which is a negative 4y equals 12. And I'll divide both sides by negative 4. And I get y equals a negative 3. So my y-intercept is 0, negative 3. Now we'll take these 2 points and plot them on the graph. 4, 0 is here, and then we have 0, negative 3, which is here. If we look at my inequality sign, I have an equal to line underneath the sign, so that means that my line is going to be solid. Now I want to decide where to shade on the graph. Do I shade above the line or below the line? In order to determine this, we're going to choose a test point. And we can choose whatever point we want as long as it's not on the line. I'm going to choose a test point of 0, 0. And we'll plug this into the first inequality. So I have 3 times 0 minus 4 times 0 is less than or equal to 12. 0 minus 0 is less than or equal to 12. So 0 is less than or equal to 12. That is a true statement. So that means that I'm going to shade above the line to include that 0, 0 point. So all this will be shaded. That's the graph of my first inequality. Now I'm going to graph the second inequality. So we'll look at our second inequality, and first you'll find the x-intercept. So I'll plug a 0 in for y, and I get 4x minus 0 equals 8. So 4x equals 8. Then we'll divide both sides by 4, and we get x equals 2. So my x-intercept is 2, 0. Next we'll find the y-intercept. So we'll plug in a 0 for x and solve for y. So I have 4 times 0 minus 2y equals 8. 0 minus 2y equals 8. Negative 2y equals 8. We'll divide both sides by negative 2, and we get y equals negative 4. So my y-intercept is 0, negative 4. Now I'm going to take both of these points and plot them on the same graph that I plotted the first inequality. So we'll find 2, 0, which is here, and then 0, -4, which is here. We'll go to our inequality and look at the sign. We do not have an equal to line underneath the sign, so I know my line is going to be dashed or dotted. Now I want to decide which side of the line to shade. So we can choose whatever point we want as long as it's not on the line. I'm going to choose the point 1, 2, which is there. So I plugged in a 1 for x and a 2 for y into the original inequality. And we'll solve, so we get 4 minus 4 is greater than 8, and then we have 0 is greater than 8. That is not a true statement, so that means the point 1, 2 is not going to be included in my shading. So that means that I'll shade on the other side of the line, which is over here. Now the solution to my equation is the graph of the two lines plus the shading of the overlap. So I only want to include the shading of the overlap of the two lines. And as you can see, the overlap is going to be within these two lines here. So my solution is what you see in the graph now. I have my first equation with a solid line, that's the black line, and then I have my second equation with a dotted line, that's the blue line, and then the overlap of the shadings is represented by the purple shading, which is in the top middle of the two lines.